All right. Hello, everyone. I'm Bernd, and today is day 11 of Advent of Code. So today's puzzle was about playing monkey in the middle. So we have a few monkeys, and they're throwing around items, and we essentially want to keep track of where those items go and calculate some stuff from it in the end. So our input is given by a lot of those, a list of monkeys, and each of them is given by something like this. So we have a plenty of information in there. In particular, we have a list of starting items, and this is the so-called worry score, an operation, how to update the worry score before the item is thrown, and then a test, which takes the worry score and does some tests, for example, if it's divisible by 23, and then two other monkeys that the monkey will throw the item to, conditional on this test. And yes, so at each round, a monkey will throw all these items to other monkeys, and we essentially want to keep track of what's happening. Okay, so let's have a look at the code. So we just need some, of course, we need to read the file and split it into lines, and then we'd also define some helper function, which is all integers in a line, and the first integer in a line by these regular expressions, which will help us parse the file. And then we'll have a class monkey. So we make it a data class in order to save some lines of code, and it will have attributes such as an ID. We'll have a list of current items. We have a way of updating the so-called worry score at each iteration, which is a function that takes an integer as an input and returns an integer. We will have a way to get the throw2 ID, so the ID of the next monkey. Again, we'll take a worry score as an input and return a monkey ID. And then each monkey will also keep track of a list of all the monkeys, so we can throw items to them. And we'll also keep track of the number of inspections a monkey does, or number of throws a monkey does, because that will be needed for the solution value. Okay, so what can a monkey do? It can throw the first item as a method. So there we just remove the first item of the current items list, get a worry score, update the worry score, find out the new monkey ID, and then for this monkey, for the corresponding monkey, we'll receive an item with the new score as a value, and we also add 1 to the number of inspections. We can throw all items, which just goes through all the items and throws them. And we can also receive, and monkey can also receive an item, so the item will be an integer, and it just appends it to the list of current items. And then what we need to do is we need to parse such a monkey from the text. So one monkey particularly, that would be the text that determines the monkey, essentially. So what we have, we pass it from a list of lines, and we'll first get an iterator over those lines, so we don't need to keep the indexes of all these lists, but we can just always look at the next line. So the first line gives us the ID of the monkey. We just get it by the first integer in the line. Then we look at the next line. This will give us the list of starting items, and it will just be all integers in this line. Then we will look at the line that defines the operation. So in particular, we have this operation string, and then we pass this string. How can we do that? So essentially, it's like 3 options for the operation. It's either like the old value squared, the old value plus a constant, or the old value times a constant. In each case, we find the corresponding constant and return the corresponding function. Okay, so that gives us the operation. Then in order to update the worry score, we are told we first apply the operation, and then we do this integer division by 3 as well. So that would be the update worry score function. And then we have this get throw2 ID, which we also need. So we use the next 3 lines in order to parse this. So we just make sure these 3 lines are like test divisible by. Then it gives us if true, throw to monkey, and if false, give to monkey. So if that's the case, the test divisor will just be the first integer in the first line, the true monkey ID will just be the first integer in the second line, and the false monkey ID will just be the first integer in the third line. And then we can have this data class, test modulo, which just takes these three attributes, and then if the worry score modulo this value, 0, it returns a true value, otherwise it returns a false value. And having it as a data class means we can access those values later on, which will be useful in part 2. Okay, so that will give us this getThrow2ID function, and then with all of that information we can create a monkey. So we can parse this set of lines. In order to parse all the lines of the file, we'll just always index the list of lines at the indices where a specific monkey is, parse those lines, and then append the monkey to the list of all monkeys. Okay, so that enables us to read all the information from the file. So now we need the code to actually run, apply the throws. So in particular, we have a doRound function, which just goes through all the monkeys, and each monkey will throw all its items, which already predefined. And then in order to solve the problems, we'll parse the lines to get the list of all monkeys, and then for 20 times we do a round of all monkeys throwing all items to other monkeys. And then the solutioner will be given by the number of inspections, by the highest number times the second highest number in terms of inspections. So we just get the inspection count, sort it, and return the product of the highest two values. Okay, so a lot of code. Hope it's not too bad. So it turns out the test works out. That's nice. So we can also run it on the main input and get a result. So things change a little bit for part 2. So in particular for part 2, we have many more rounds. Instead of 20, we have 10,000. And also we won't do this division by 3 anymore. So the very score will not be divided and will increase and increase and increase and get larger and larger. So we need to change the parse monkey function and set this then the update very score will be just the operation, no more dividing by 3. And then in principle we can use a lot of code from part 1. However, we need to be a bit smarter because the numbers, the very scores will grow and grow and grow, and our program will get slower and slower. So we need to be a bit smarter, and for that we can notice that all the conditions are like test divisible by something, test divisible by something, test divisible by something. And then we can note that if we take the product of all these values and add or subtract it to the very scores, none of these conditions change because that adding something times 23 doesn't change whether something that the value is divisible by 23 or not. And also all these operations will not mess up with or hurt, will not change anything. So and that also means we can take the very scores and calculate, take the values modulo the product of all these divisible by scores, and that will be exactly the same result as not considering them because the very scores do not come in any other way or not important in any other way. So that's exactly what we can do in the code as well. So in order to solve, we will again get all the monkeys by parse the list of lines. And then we will get all these test modulo values because this was a data class, we can access it like this. And this will give us a list of all the test modulo values. And then, for example, we can take the product of all of those. And then after doing each round, we can take all the monkeys and all the current items and subtract or take their values modulo the modulo product, and this will not change the kind of monkeys items will be thrown to, and since that's the only way we count, we don't change the process there. So with that, the rest is the same as before. Again, we're interested in inspection counts, so we can get that from all the folder monkeys, we can sort them, and then take the highest two values and multiply them in order to get a solution. If you run a little test, that looks all good. If you run it in real input, it also gives the right solution, so that's nice. And yeah, that's it for day 11. I hope you enjoyed today's puzzle. Best of luck for the future, and see you around.